Hi everyone. So this is third and final piece of lecture 8. This is a supplement to the main lecture on how to do file input and output, file I/O, and plotting in Python. Well, let's just dive right in. So at the beginning here, we have a bunch of references of things to look up. I think these are all here just for your benefit. They're not like required reading or anything. But there's a lot of things here that are valuable. So for instance, we're going to talk about loadtxt and savetxt. There's a documentation for that. There's rules about how to make good figures. There's lots of examples of figures here, of how to make different plots. So there's a lot of stuff to dig into here. Just to point that out. Okay. So the first thing I want to cover is reading, and then I'll follow that up with writing of text files in NumPy. And NumPy makes it really convenient to read and write text files using these commands or these functions, loadtxt and savetxt. So the first one here is np.loadtxt, and essentially what it does is it takes a file name, okay, and then a delimiter, be that a comma or a space or a tab, all right, and the file name is the name of or is a string rather of the name of the file that's in the local directory. So we need to talk a little bit about local directories. So let me pull up where my directory is here. So here I'm going to go to Documents. Let's see, where am I? All right, so this is just my particular directory structure. This is for lecture 8. We're doing the Python video. Okay, and you notice that where I'm running this file here, which is this guy, lecture 8, example file I/O and plotting, edited. This should be, I think I'm actually in the wrong one. So let's just save this as where I want it to be, not in the video lecture, but in here. All right, right there. All right. So that's where I want. And notice this up here. This is where my directory is running at currently. Okay. So if I do something over here like ls, this is going to, or pwd, excuse me, this is going to tell me where my working directory is, which is the same thing as this guy up here. So I want to change this working directory to be the directory that I'm currently running this file from. So I'm going to go here to, let's see, it was in lectures 8, Python, right there. Choose that directory. Okay. Now if I do pwd, print working directory, that tells me that I'm in that directory. All right. And I want that because I want to be able to load these. Oh, that was the wrong one to look at. This one right here. I want to be able to load the files that I have in here. So if you haven't already, download the zipped folder with all the data in it and extract it and put it in your working directory. All right. And I need that because when I go to load the file, I want to put the file name, but I don't want to have to put all the stuff of where to find it. Okay, so then I can run this, and it should find where that data is. All right, and the way that loadtxt works is I put in the name of the file, okay, and I put the delimiter. This is a CSV file. So you remember CSV files. If I open that up, I'm going to open this with just my text editor. Okay, and you remember that a CSV file looks like this. It's just a bunch of data separated by commas. All right, and so that's what I'm telling it is my delimiter, and then that dumps it into a variable called my data. Now my data is actually just a NumPy array. So my data.shape, for instance, it says it's a NumPy array that has 2,000 rows and 101 columns. Okay, so it's big, but that makes sense because this guy, I guess maybe I shouldn't have closed it. Open it with my text editor. That guy was big. It's got 2,000 rows in it, right? If I keep scrolling down, it's got a bunch of stuff. Okay, so it's already pretty big too. Okay, so that's how you read in a text file. If you have something else like a .dat file or something else, then you can put a space delimiter or some other kind of delimiter. So let's do a practice here. Let's load ratedata.csv. So the first thing to do when you want to load a file, I think, is to open it. So if I come over here and I want to open it with my text editor and come look at the structure, right? So this is comma separated, but it has a header. So that's a little different than what I've done before. So what I want to do here is, let's call it rate data is equal to np.loadtxt, and I'll do rate data.csv. Okay, and then delimiter, that's a comma separated, so that has a comma. And look, there's another thing in here that's called skip rows. And I want to skip the first row. I want to skip the header. So I'm going to say skip rows equals 1. Right? Now I run that. Okay. It says, oh, I spelled delimiter wrong. It says load text got an unexpected keyword argument. Delimiter. I want delimiter. I run that one, and it runs, and I should be able to check rate data.shape. Okay, 126 by 2. What happened if I didn't put in the skip rows? Let's just try that for a second. I'll come in at the end of that line and see what happens. Okay, this has a problem. It says could not convert float tmin, could not convert string to float. So it's got a problem in that as it's trying to read in this data, it tries to read that in as floats because all these others are floats, and it doesn't like that. Okay, so if you want to skip a header, you need to use this skip rows feature, which is pretty convenient. Okay, what about writing files? So suppose I want to write a file. It's very similar. I use, instead of load text, I use np.savetxt. And I give it a file name, a string with the name of the file. I give it the data. If there's any formatting or delimiter information, then I can give that there too. Okay, so here let's look at an example. I create an array. That's the data that needs to go in here. It needs to be either a variable, just a single variable, or a numpy array. And remember, a numpy array can be big, it can be a vector, it can be a two-dimensional array, it can be a matrix, but it should be something like that. Okay. If I don't put anything for delimiter, look, I spelled delimiter wrong there too. If I don't put anything in for the delimiter, then it's going to assume it's a space. So let's just see how that works for a minute. So I'm going to say t is numpy linspace 0 to 5. I'm going to have 201 of them, and then I'm going to do a save text t.dat. So let me run that guy, and let's look at our function here. Let's open t.dat with text editor right there. Okay, and whoop, there it did. Print it all out. Perfect. Okay. What happens if instead of a comma separated, or instead of this, I wanted to do comma separated delimiter? Sorry for the phone call. I can say delimiter is equal to a comma. All right. Let me try that. Let me run it. And we'll open it up and see what it gives. Here, t.dat, open with text editor. And look, it didn't do anything different. Huh. Well, the reason it's not doing anything different is because it's giving new lines to each of these things. Okay. So that's okay. You know, I could call that t.csv if I wanted instead. All right. And it would do the same thing. All right, so t.csv, I can open that, my text editor. All right, same thing going on. All right, so that one's pretty easy to export just a simple array. What happens if I would like to put together multiple arrays, all right, that aren't in the same variable, and I'd like to put them together? I can do that too. I need to use this function called Vstack. Okay, Vstack is something that makes a two-dimensional array out of 1D arrays. So suppose I have this guy here, which is some time, linspace from 0 to 1, and I have some concentration data. Say it's millimolars of something, and I have some solution here. All right, I can use this function numpy.vstack, and what I do is I make a list of the two values, t and c. Okay. And then it turns out that I need to do a transpose to make them go this way. Okay, oh, where am I going? So to go from that way to that way, if I remember right. Okay, and so that makes them stack vertically like that. And so you put the .t at the end. and then I can just save that data together now that I've made a new array. So let's run that and see. I'm going to move this practice off of here and run this piece. So rate data.dat, come over here. Let's open rate data.dat, open with my text editor. Okay, and look at that. It's got 10 points. It's stacked 2 of them. All right. So if I want to make it more than 10 points, maybe I want to make it 100 points. That's kind of fun to do. Look at this here. Open with a text editor, and now it's a lot longer, right? 100 points, but it's stacked vertically. What happens? Let's play around a little bit just to see what happens if I don't do the transpose. Okay, it saved it. Didn't mess it up. But if I look up in here, rate data.dat, open with my text editor, now it's printed them long ways. You kind of can't see because it's wrapping around, but if I make that longer, you can see that's doing that. I can show that a little easier if I open it with this application called Vim, which is a text editor. I can say set no wrap. Okay, and you see it's just made 2 really long lines. Okay, so the reason I put the transpose is I don't really want them to be long lines like that. I want them to be vertical. It's easier to see. So you don't have to put them in like that. You don't have to put a transpose, but I like to. I think it makes it a lot better. Okay. All right. So that's how you stack a bunch of things. If I wanted to have multiples of these, I could stack them. They do all need to be the same length though. So if T and C were all different lengths, then I'd have a problem. If that's the case, if you want to write multiple things, what you should do is just append the data onto the end. Okay. So or save it multiple files. There's no reason you have to put things all in the same file. You can have different files that you save stuff to. Okay, so let's do this practice. Save x and y to a file, comma delimited file. That's kind of a funky comma delimited file called Gaussian.csv. So we have x, y. This creates a function, and that's a Gaussian function. That's why I'm going to call it that. So let's see. The first thing I want to do is stack those guys together. So np.vstack of x and y. All right. And remember, I got to put them in a list. And I want to take the transpose at the end to make them stack up. And then I do np.savetxt, and I'm going to call it Gaussian.csv. And I need to give it a delimiter with an I, and I'm going to give it a comma. Okay. And I'll run that one. Now it says I'm doing something. Save text missing 1 required positional argument. Oh, totally forgot to give it the data. So I need to give it the data right there. Remember, I give it the name, the thing, and then I give it the data, and the delimiter comes after. Run that thing. That runs fine. Let's pick this up. Gaussian should be here somewhere. Gaussian is right there. Let me open it with text editor. And boom, there it goes. And look, it's comma separated. All right, great, perfect. Remember the rate data we made earlier that didn't have anything separating it. Didn't have that, and this one right here should though. This one should have spaces because we didn't say anything for delimiters. It should have spaces. Okay, so that's importing and exporting data. Plotting. So plotting in Python is extremely powerful. I personally use it all the time, and I use it to make figures for publication. It makes very high quality figures. I think it's much better. This is just my personal opinion, but I think it makes much better plots than Excel. Its stock plot isn't maybe as pretty, but it's very easy to make something that's quite pretty. Okay, and it's also very easy to export the plots, which is harder to do in Excel. So we're going to use a new module. This module is called the matplotlib module, and there's a submodule inside that called pyplot. So the command to import that is this command right here, import matplotlib.pyplot as PLT, because you certainly don't want to be typing matplotlib.pyplot every time you want to make a call to a function from this module. All right, there's a bunch of things you can get. There's some interesting stuff here about trying to get your plots to show up, whether they show up as pop-up or over here in this. I can't remember which I set up, but if you can go ahead and read through these notes right here to try to follow how to do it. Basically, it has to do with making it inline or making it not inline. So the basic plotting tool, what you do is you have to define some x value and some y value, and then you do plt, which comes from this guy right up here, dot plot x comma y. All right, so let's run that. Okay, and as you can see right here, my plot shows up, and I makes a little box, and I have x and y, and it plots my function. Okay, now I needed to give it explicit points to evaluate my function, just like in Excel where I have 2 columns of data, right? These are my 2 values of data, and they're explicit. If I make this 101 points in my linspace, that's going to give me a smoother curve than when I only had 51. You can see there's kind of jaggedy edges on some of those spots. All right? So that's the basic way to do a plot. There's lots of things you can do to add onto that plot. So you can give it, I'm going to make this go back to 51 for now though, because I think it makes these. Okay, so you can change the style of the lines. So if I run this one here, hopefully you can see this. Maybe I'm going to show you how to make it a little bigger because this one's a little small for me. I'm going to do this plt.figure. Fig size is, let me make it 8 by 6. Okay, let's see if that one's too big. That one's still not too big. Let's make it even bigger. Let's go 12 by 8. Okay, there you go. That's easier to see. All right, so I'm going to just, so that's one thing you learn right there. If I want to change my figure size, I can add that before. All right, I can change the style of the lines. So if I put a dash here, that'll draw a line between my points. All right, I already had a line before. It does that one by default. If I put a circle or put an O, it'll do filled circles, all right, at each of my data points. So notice if I went back here and changed this to 101, and then I run this again, okay, now there's more data points there than there were before because I ran 101 of them, all right, so it's a lot more points in between. Okay, this gives me labels, so I can have an x-axis label. So I do plt.x label, gives this one. Plt.y label gives this one. All right. If I want this font size is driving me nuts, I can do plt.rc. Okay, and I can do font size is 14, and that'll make my font size bigger. That's even still small for me. Let me go all the way up to 18. Get some bigger font sizes. Okay, now you can see what those labels are. It changes my font size. Y label, I can add a title up here, and I can do a legend. Okay, I need a list for the legend because I need a list for each one of the points, but I can do that and say that's my curve. All right. There's some more formatting options down here I can get into in a second, but why don't you take a practice? Let's see if you can load rateData.csv and plot T versus C, okay? And then play around with the plot and label the X and Y axes as follows: T in minutes and C in millimolars. Go ahead and see if you can do that. Okay, so you've unpaused the video by now, hopefully. And well, I guess you are for sure if you're watching this. And so let's see if we can go ahead and load. So we do np.loadtxt and we said rate data.csv, and the delimiter is a comma. Okay, and we're going to put that in something. Now I want to point out something that's kind of nice. So rate data.csv, let's see if it'll pop up my menu again. Oh, I totally spelled delimiter wrong. Okay, if I put, oh, I don't remember what it is. Well, this is good practice as anything. Let me Google it. I go np load text. Np load text right there. Okay, it has this really nice argument called unpack. Okay, and so if there's multiple columns, it will allow me to unpack those columns. I always forget what the keyword is, but the keyword's unpack. So if I type unpack equals true, I can come over here and put T and C, T comma C, and that will unpack the different parts of rate data. So if I come over here, remember to open with text editor, it's got two columns, T and then C in this column. All right. So I want to separate those. Oh, and I need a comma. That's why it's freaking at me. Okay. Let me run that and see. Do I have T? Yep. Do I have C? Yep. I've got both of those. Both of those are arrays. Great. So now I can do plt.plot T comma C. Where'd it go? Oh, is that the same one? No, it didn't like that. It's giving me a problem. It says, it says could not convert string to float. Oh, we already had this problem, right? We need to skip rows 1. There we go. Okay, now it plots it. Now, notice that it's plotting this on top of my same plot from before. So to get rid of that, I can do plt.figure. I need a new figure, and it'll put a new figure for me. And if I want fig size equals, what did I have? 12 by 8. Okay, it'll give me my figure that I want. Great, look at that. There's my plot of T versus C. Now it says to label the X and Y axes. So X label is, let's see, T in minutes. And my Y label is C in millimolar. And run that. There we go. T in minutes, C in millimolar. There's my plot. Maybe I'd like to do squares for my data points, just to show how to do that. There you go. There are some squares for my data points. Maybe I want them to be, let's see, what's an easy color to do? Red. Red is R. Red squares. There we go. Red squares for my data points. All right, so there's the rate data. So this last part here is just a couple extra options to show you. So if I want to put multiple curves on the same plot, I just call the plot twice. All right, the figure creates a new figure. All right, and if I just call the plot function twice, it'll plot two things. I can change my scales to be logs. I can change the limits. I can give a title, and this plot.show makes it show up right there, especially if I need it to pop up. So I can run that thing, and look here, I make this nice plot. It's a little small here. I could come over here and make it fig size 8 by 6, or what did I say, 12 by 8. That'll make that guy, fig size equals 12 by 8. Okay, that makes my plot bigger. I'm on log scale. I think this looks really nice already as it is. In addition, there's all sorts of things you can do. I can make my lines, I can make my colors green, I can make my colors blue, I can change the size of the markers, I can give complicated labels. There's all sorts of stuff. I don't expect you to know all this. I just want you to see that you can make complicated functions, you can do lots of things, you can have Greek letters, you can do all sorts of really nice things with this. Okay, so if you want to know how to do all this stuff, you can read through this for a specific example here, but go to the documentation and look at the examples. There are so many examples in this gallery here of really cool things that you can do. Let me just pull it up so you can see. There's all sorts of things. There's bar charts, there's histograms, there's just all sorts of fun, crazy stuff that you can learn how to do. And if you Google around, you can find some really interesting things, like just clicking on that. It's got the code for you. It has the plot, how to make it. You can make some really beautiful plots with matplotlib. Okay, so this has been the quick and dirty introduction to file I/O and plotting in Python. I hope it helps, and I hope that you have a great day.